Hello and welcome to a new video. This is for Pre-Algebra Lesson 12, and today we're going to talk about the distributive property. So this is really one of the cool things that we're going to use in algebra and just use like for the rest of our math career. So it's a super important property and I'm really excited to show it to you. If you would like to download a free notes page, you can click the link in the description and head to my website. Like I said, free notes page, you can use it to follow along. Let's get started. Okay, I've got the distributive property here, but I want us to think about a couple problems with numbers to see if we can understand what the distributive property is telling us. So let's look at this situation right here. And I'll go ahead and put a times symbol here as well, but we don't need that times symbol. If the 3 is just in front of the parentheses, that means multiplication. So order of operations says that we should do 2 plus 5 first, which is 7, and then times by 3, and we get 21. But the distributive property has another way that we could go about this. The distributive property says that if I have something outside of a parentheses that I'm multiplying by, and inside is addition or subtraction, we can distribute the number outside to the 2 or more things that are inside, and that will get the same answer. So what we do is we think of this as 3 times 2, because of the 3 and the 2, then we put a plus in the middle, and then we do 3 times 5. And you see I drew arrows up here to kind of remind myself visually, okay, I need to do this to both of these. That's 3 times 5. Let's see if this gives us the same answer. So 3 times 2 is 6, 3 times 5 is 15, and 6 plus 15 is 21. So these do give us the same thing. Now you may be thinking, the first way seemed faster or easier, or maybe you like the second way better. I don't know. Any of those are an option, but the distributive property is really used later on in algebra whenever we don't have just numbers involved, whenever we put letters in as well. So we might practice some this year with it just being a bunch of numbers. We're also going to practice though with there being variables involved. Just know that just because it might seem longer to do it this way, it's because we're practicing a skill. So what I just did with these numbers 3, 2, and 5 is the same thing that's being described by my like math written formula kind of thing for this property. We've got a on the outside, and then inside the parentheses is b plus c. Then that says it equals a times b, so that would be us doing a times b plus, because of the plus in the middle, and then a times c. So see how they both have a's. We're multiplying, so it's just kind of a way to rewrite this that sometimes will be helpful to us. Let's look at some examples and see what kind of problems we're gonna have to do in this lesson. So these first two say rewrite each expression using the distributive property. Now, I'm gonna be honest, sometimes it's hard for me as someone who's taught algebra and pre-calculus and calculus to go back to doing pre-algebra and really really know how to communicate to you. So I'm going to do my best to really explain what's happening here. So if we use the distributive property, it's basically saying, hey, get rid of these parentheses. And we've actually got a case here where that is the best option, because inside my parentheses is e plus f. Normally I would try to do that first because it's in parentheses, but we can't actually add e and f together. They're not the same letter. We have to assume that they are representing two different things, and so we can't just try to combine them into like ef or in some way. That's not how it works. We leave them separate. What we can do is we can distribute this 4. So I can do 4 times e. I'm going to use dots because we are using variables here, so we might end up with some x's, right? So 4 times e is 4 times e, and then 4 times f, put a plus in the middle because of that plus in the middle, get 4 times f, and then we think about, is there really anything I can do to this to make it look nicer? There's not. We still can't add e and f together, even though now we have 4e and 4f. What we can do is we can rewrite it without the dot in the middle, and that's about it, 4e plus 4f. So this is one of those things, I don't know if I've said this clearly before, but when we see the number and letter right next to each other, that means multiplication. We're saying 4 times e. It also means what we're doing is we have e plus e plus e plus e. We're just writing it shorter because we're saying we have 4 of them being added together, so there's 4e. Let's try b. We've got 5 that we're going to distribute, so we're going to do 5 times 3x plus in the middle 5 times 4y. Okay, so 5 times 3x, the way this works is that, oh, I was going to use dots and I forgot, and this is the one that has x's in it. It's going to be super helpful for us to start using dots for multiplication. The more we see x's, the more important it'll be. Okay, when we do 5 times 3x, we're saying I have 3x 5 times. So 3x plus 3x, and so on. So what that means is I do 5 times 3 to get 15, and then I still have x next to it. That's how that multiplication works. 5 times 3 is 15, and then we keep our x right beside it. 5 times 4y means I have 4y that I'm adding together 5 times. So what does that make that number be? 5 times 4 is 20. It's a plus because of the plus in the middle. We are going to see, I think, in a little bit some subtraction happening and how that changes things. Again, because x and y are not the same letter, we can't put them together. We would just leave our answer as 15x plus 20y. So this example 2 has the same instructions, rewrite using the distributive property, but we do see some subtraction here. So let's see, 7 times 2a is first. Now, there's a few different ways we can think of how to deal with this minus sign. Probably the easiest way for us right now is to say, if it's a minus in the middle, we'll just go ahead and put a minus in the middle of ours. The other way to kind of think of it is to think of it as 7 times negative 3b, which does end up being a negative. So it's kind of up to you which way you want to think about it. So we need to do 7 times 2, which is 14, to get 14a, and 7 times 3, or negative 7 times 3, and get negative or minus 21b. So that's our answer. They're a and b, which are different letters, so we can keep them separate, or we need to keep them separate. B. Now this time we're distributing a letter to 2 other letters, okay? So we're going to do a times m. I keep accidentally switching back to x, which has never been a problem I've had before in my life. A times n. So we can't do anything to this. Like, we don't know what any of these letters are. So a times m just ends up being a and m next to each other. A times n ends up being a and n right next to each other. We can't add them together because m and n are different. So this would be our answer. Now, let's think about this backwards, because what's happening with the distributive property is that we've got, an answer that looks like AB plus AC, but they have a common thing because of us distributing it. So we can also go the other direction basically and say, hey, if there is a common thing here, I can write down that common thing outside a set of parentheses. Inside put, what's left over if I take out the common thing. And basically it's like a reverse distributive property. We actually call it factoring. And that's something that we'll do a lot of in Algebra 1. So get excited, I guess. So let's look through this and see if we can come up with a common factor for these. This has two terms. We call these terms. So this term is 2a, this term is 4. Let's think about what they both have. Let's look at our numbers and say, okay, is there a number that I can divide both of these by? The answer to that is yes, we can divide both of these by 2. That means that that is a common factor they have, because we can split this up in such a way that we can see, okay, we've got 2 times a plus 2 times 2. We can see that they both have a 2. So what we can do is we can write that 2 in front, and then we take the stuff that's left over, this a and this other 2, and we put it in our parentheses with a plus sign in the middle. It's almost like we're creating our own distributive property problems. If I wanted to check my answer, I would distribute the 2 and see if I get what I started with. But this is my answer, 2 times a plus 2. It's kind of weird to be doing it both ways here, but we are. How about on B? We've got 8x plus 4. What do these have in common? So we could divide both 8 and 4 by 2, but there's also something bigger we can divide them both by, which is 4. So if I think about that, if I say, okay, this would be like having 4 times what would give us 8x? Well, to get 8, we'd have to do 4 times 2, right? So if I'm trying to kind of separate this out, I would say, well, there are 4 2x's. If I want to split up this 4 so that I can see a 4 times something, well, that would be 4 times 1, right? Not 4 times 2, that'd be 8. Can't be 4 times anything other than 1. So then our next step is to say, let me write that 4 on the outside, and on the inside, let me put what's left over. And so this is one of the things that can be tricky, is that because this was 4, you might be thinking, oh, I don't need to put anything here. But we need to put plus 1 so that when we go back and look at the distributive property to check our answer, we end up getting 8x plus 4. If you put 4 and then you put 2x in parentheses and that's it, well, that's just 8x. So we've accidentally gotten rid of the information that tells us there should have been a plus 4 there. So it may take some getting used to here on thinking about this, but if the thing, if the common factor that we have is the exact same as one of our 2 terms, that term just ends up being 1 inside the parentheses. Let's look at another one of these. So we have some things in common here. 5x plus 15x. We've got a 5 that can go into both of these, but we actually also have a letter that they both have in common, right? That both of these have x's. So we're going to be able to take out not just a 5, but also an x. So what does that look like, though? If I rewrite 5x as 5x times something, that'd be 5x times 1. If I rewrite 15x as 5x times something, I have to think, okay, what times 5 gives me 15? That would be 3. But on both of these, I'm not going to need an x on the second part of this because the first part had the x. So 5x times 3 is 15x. If I put another x here, 5x times 3x would actually be 15x squared, and that's not what I have here. So don't want to put an x there. Now let's rewrite this. I'm going to take out the 5x, and then I'm going to say, okay, what's left over is 1 from this one and 3 from this one. So 1 plus 3. So, and I'm just going to leave it like this. We actually could add the 1 and the 3 together, but it didn't really ask us to simplify. I think it's more important that we're just showing how the distributive property works. So let's look at B. Well, there's a lot of stuff here. We've got 12MA minus 16NA. So what do these have in common? For our numbers, 12 and 16 both have numbers that can divide into them. 2 divides in, but 4 divides in also. We want to pick the biggest number we can. Now we've got 3 different letters in this problem. Are any of those 3 in both of our terms? Because if so, those terms have it in common. Well, look, we have an a in both, so let's write 4a as our common factor. So now we need to think about how this splits up. So think about the 4 and the 12. How do I take 4 and times it by something to get 12? I would have to have 3. Then what about the letters? I'm putting a here, but I still have this m, so it needs to go next to it. And we can check ourselves. We can say, do we think 4a times 3m gives us 12ma? Well, 4 times 3 is 12. A and m are different letters. We could write them, we can reverse their order. That's the commutative property, by the way, from last lesson. So we can rewrite them as ma instead of am. But yeah, this really does equal 12ma. So what about 16na? That'd be 4a. Sorry, I got distracted. So our common factor is 4a. We'd have to do 4 times 4 to get 16. Then we need to put the n in because we haven't put it anywhere else. So our common factor is 4a because it's in both of them. And then that's not what I meant to write. And then in parentheses, we're going to put what's left when we take out the 4a, which is 3m. We're going to put a minus sign because this problem has subtraction, and then we're going to put 4n. And that's our answer on this one. Okay, example 5. Show that the distributive property works by finishing the equation and simplifying each side. So what we're going to do here basically is work this out 2 different ways to show that this works. Kind of like what I did at the very beginning of the lesson. So we're going to work it out one way where we say, okay, let's do 5 plus 7 and get 12. And then let's times it by the 3 in front and get 36. Then we're going to do it a second way. We're going to distribute the 3 using the distributive property. So 3 times 5 plus 3 times 7. And we're going to say, okay, what does this give us? 15 plus 21. Does this add up to be 36? Yes, you might need to go out to the side here, right, to do your addition. But yeah, that does equal 36. So what we've done is we've said, okay, yes, this works. Now, one of the skills or types of problems we're going to see more and more kind of in math is this idea of like showing that something works. When you're showing that something works, you got to put as much work as possible down. Even if you're doing something in your head, you should be writing down what that thing is that you did in your head. If all you do is write down 36 for the answer here with nothing else, you haven't really done the problem. You're right. You get 36 when you do this problem. But that's not really what it wanted us to do. It wanted us to show the process that it took to get 36. So just thought I'd throw that up there. Let's do a few more of these. So we're going to start by going ahead and figuring it out the good old-fashioned way. 6 minus 2 here is 4. And then negative 10 times 4 is negative 40. So that's what we think we're going to get when we do the distributive property as well. So this might be a little tricky because of our negatives. We need to do negative 10 times 6. Okay, put your minus sign for right here because we're subtracting. Then we need to do negative 10 times 2. I'm going to put that negative 10 in parentheses and times 2. Alright, so this first part isn't so bad. Negative 10 times 6 is negative 60. Remember when we multiply with negatives, if there's one negative, it makes the whole thing negative. This next part is a little tricky because we do it a couple different ways, whatever makes the most sense to us. One way is to say, let me do negative 10 times 2 and get negative 20 and put that there so that then we can deal with the 2 negatives. Or it could be that you can do this kind of at the same time to say, okay, I know negative 10 times 2 is negative 20, but there's a negative in front, so it changes it to a positive. The other way would have been for us to, when we distributed, said this is negative 10 times negative 2, which gives us a positive 20. However we think of it, we should end up with negative 60 plus 20, which does in fact give us negative 40. Okay, so that was a tricky one because of those negatives, right? So we're still trying to use all those negative rules, hopefully well, to figure out the answers here. That's kind of the process we go through on this one. Okay, let's look at this one. We've got a couple of A's in here. So do you remember what we do whenever we have letters that are the same? We can add them together when they're the same letter. So having an A plus another A would give us 2 A's. I don't necessarily need to have that in parentheses anymore. I could have just put a dot in front. 6 times 2A, we do 6 times 2 and get 12A. Now let's distribute and see if we come up with the same thing. So as long as we're doing the distributive property right and our initial math right, by the way, we should get the same thing. The distributive property is something that is absolutely true. Like if we're using unless we decide to make up our own kind of math that doesn't follow the same rules as algebra, which good luck with that. But okay, anyway, 6 times A, right? And then 6 times A again. Well, 6 times A is just 6A. And so 6A plus 6A would be 12A. Ta-da! So that shows that, yeah, the distributive property works here. Last one. So our first way, 4 plus 3 is 7. I don't know why I keep using parentheses here. I don't need to use parentheses after I've added. I could just put a dot in between. I'll go ahead and do that. Doesn't really matter. Multiplication is one of those things you can represent a variety of ways. Negative 1 times 7 is negative 7, because a negative times a positive is a negative. Let's distribute this. We need to do negative 1 times 4 plus negative 1 times 3. I do think it's helpful to put this negative 1 in parentheses because of the plus in front. I think it looks better that way, but it's not strictly necessary. Negative 1 times 4 is negative 4. Negative 1 times 3 is negative 3. We can think of this as negative 4 plus negative 3 or negative 4 minus 3, whichever way makes more sense to us. Either way, we're still actually supposed to do the same thing in our head of saying they're both negative, so they make each other more negative, so we should add these together or subtract them and get negative 7. So it's going to be important for us to kind of practice and check our answers to make sure that not just the distributive property is going well for us, but also that the math is going well for us, especially on ones that have negatives involved. It's going to be helpful probably to double check and see, okay, did I do the negative rules right? Because we haven't really, it hasn't been that long ago that we didn't know what to do with negatives. Now we do, so we need to make sure we're doing them right. Thanks so much for watching. I hope that you'll like the video, like literally and also figuratively. I don't actually know which one is literal and which one is figurative in this case. Like, I literally hope you like it. Maybe they're both literal. I would like you to literally like it, as in hit the thumbs up button. And I would like you to literally like it, as in enjoy watching it. Although this is the end of the video, so it's not like I could do anything at this point to make you like the video if you didn't already like it. Okay, also, if you've made it this far, please subscribe. So, thanks so much for watching. I'll see you in another video. Bye.